Hello, my dear students. So, this is a video lecture that is meant as an enrichment material in our unit in kinematics. So, in this video lecture, I am going to show you how you can use motion diagrams or motion graphs, rather, in solving problems related to kinematics. I am going to show you two problems and solve it, and then I will give you one item for you to try the process that we did here. Okay, so this is the first one. First, let's read the problem. A car starts from rest and moves in a straight line. The position time graph shows that the car travels 10 meters in the first 2 seconds, remains at rest for the next 3 seconds, and then moves back to its starting point in the next 5 seconds. So, the goal of this video lecture is to show you na pwede kang mag-create ng position time graph or velocity time graph para mas ma-visualize mo yung isang description ng motion in the problem solving, in the hope that maybe you will be better able to solve it. So, just keep in mind na even if hindi sinabi sa problem na you draw a position time graph or a velocity time graph, that keep in mind that it's an option for you. So, what are the unknown or what are the required in this problem? The first one is we are asked to get the car's average speed during the entire 10-second period. 10 seconds, so 2 seconds plus 3 and then 5 seconds. We have three motion segments here, and it all adds up to 10 seconds in its entirety. And then the second required is what is the car's displacement after 10 seconds? Okay, so we are looking for average speed and displacement or total distance covered. So from the problem, I guess we can predict na yung ating motion graph, yung ating position time graph would have, again, three segments, segments A, B, and C. So again, our first step when problem solving is to draw a diagram. In this case, it would be the graph. So this is my graph for problem number 1. So again, on the x-axis is the time and on the y-axis is the position. So this is for the first segment. Sabi doon sa problem, it's moving in a straight line. So that's your clue that the velocity is constant, right? So you would be producing straight diagonal lines or horizontal lines, like in the case of segment B. So in the second sentence, the first part states that the car daw is traveling or it traveled 10 meters in the first 2 seconds. So it reached from 0 to 10 meters. Let me have a pen. So from here, it reached 10 meters and that's for 2 seconds. So that's segment A. Segment B remains at rest. So we know that when an object is at rest or stationary, the position time graph would look like a horizontal line like this. So this is from 2 to 5 seconds. That's a total of 3 seconds. And then the last part, it went back to its starting point. So that should be a clue to you about the second required. Diba? The second required is as you are asked to get the total displacement of the car. So that's a clue for you in the next 5 seconds. So again, 5 to that would be from 5 seconds to 10 seconds. Okay? So this is how my graph would look like. So from here, I'm going to make some predictions about my velocity. So my slope here is positive. So I expect that I would have a positive velocity. Here, my slope is 0 or the line is flat. So the velocity here would be 0. And then here, my graph is negative. It has a negative slope. So my velocity would also be negative. Pataas siya, so that means it's traveling to the right. And here on segment C, it's sloping downwards, so it's traveling to the left because you went back to your starting point. Okay, next. So we already have a diagram. Next step is the plan. So for the first required, we have to get the average speed. Again, when we are talking about average speed, that's total distance, emphasis on total, and divided by total time, not only distance over time. Ha? And then for the second required, to get the displacement after 10 seconds, we will just look at the final and the initial position and then get their differences. So this is the final position that's on 0, and this is the initial position that's also on 0. Okay, so solution for the first required. And nag-appear agad lahat. Average speed is total distance. So we know that on this segment, hindi siya umalis. So we don't have to worry about this segment. Segment A, it was able to cover 10 meters. So from 0 to 10. And then on segment C, the car went back. So that's from 10 meters to 0 meters. So in terms of distances, kailangan mo lang i-add yung dalawa na yon. That's why you can see here 10 plus 10. And then syempre the time is 10 seconds. So just getting the quotient of the two, you would get the average speed equal to 2 meter per second. And then for the second required, honestly, you don't have to even solve this, no? Kasi right from the start, from the description of the problem, that the car went back to its starting point, dapat nalaman na natin na yung ating displacement is 0 because bumalik lang siya sa simula. That means there is no change in his position or in its position. So that's final minus initial. That's going to be 0 minus 0. So your displacement is 0. Again, the last part of the problem solving is to evaluate. The average speed is 2 meter per second. Kasi total distance mo is 10 here and then 10 here. So that's a total of 20 back and forth. And that over 10 seconds. So this makes sense. Again, the displacement is 0 since you went back to the starting position. Okay. So let me just show you again the problem. Even if hindi ito pinakita, this part, maybe the problem stated the car travels 10 meters in first 2 seconds and so on and so forth. Take the initiative to create a position time graph or a velocity time graph kung yun yung hinihingi or kung yun yung applicable. Maybe that will help you to solve the problem. Okay, now to the next problem. A cyclist starts from rest and accelerates uniformly. Okay, so that means the acceleration is constant for 4 seconds to reach a velocity of 8 meters per second. The cyclist then maintains this velocity, that means the velocity is constant, acceleration is 0 in that case, for the next 6 seconds before decelerating. That means slowing down uniformly. Nag-slow down siya in a constant rate to come to a stop. The final velocity would be 0 in 5 seconds. What are they required? What is the acceleration during the first 4 seconds? Okay. What is the deceleration during the final 5 seconds? And the total distance covered by the cyclist. Since we are asked to get the acceleration for the first portion and the last portion of the trip, dapat ang gawin natin dito is a velocity time graph, right? In the first place, yun ang mga given sa atin. We are given with velocity values. Right here is 8 meter per second. On the second leg of the journey, sabi, maintain lang yung 8 meter per second. And then on the last part, what happened is it stopped, or the velocity is 0 in the final position. So let's try to make a velocity time graph. What is the total distance covered by the cyclist? Okay, since we can get the area under the velocity time graph, we can also solve this using the VT graph. Again, the first part is to draw a diagram. Here is my diagram for this problem. So my time is on the x-axis. 15 seconds yung ginawa ko, hanggang 15 seconds. Because that's 4 seconds for the first part, 6 seconds, so that's already 10. And then for the final part is 5 seconds, a total of 15. And then on the y-axis are the velocity values. Accelerates uniformly, constant ang acceleration. So that means makakita ako dyan ng straight diagonal, not a curve. So that's happening for 4 seconds. So here until here, what is the velocity reach? The speed reach is 8 meter per second. And then for the second portion, it maintains that speed. So nag 8 meter per second lang siya steadily for 6 seconds. So 4 plus 6, that's 10. So that's this much is 6 seconds. Before decelerating, that means it's going to slow down to a stop. Again, uniformly, word uniformly here. So my line should be straight and diagonal in 5 seconds. So that's 10 to 15 seconds. So I also have 3 segments here, segments A, B, and C. Okay, so what's the plan? Dalawa yung required natin na magsasolve tayo ng acceleration, no? Again, in the second one, we just use the term deceleration since it's a slowing down motion. Our formula for acceleration is A is equal to change in velocity over change in time. The unit would be meter per second squared since we have seconds here and meter per seconds here. For the third required, to get the total distance covered, or we can say the displacement, that's just the area under the graph. So this area. Let's try to solve it. Now, for the first part, so dalawa ang solution natin dito. One for segment A and another for segment C. Sige, just by looking at it, no? Every second, gaano kalaki ang change sa speed? Parang 2 meter per second, di ba? Just plugging in the formulas, that's final minus initial, di ba? This is the final velocity. This is the initial velocity, so 8 minus 0. This is a total of 4 seconds. So here, yeah, that's 2 meter per second squared. How about deceleration from here to here? Again, this is 5 seconds. We expect that this is going to be negative acceleration, negative ang value because again, it's deceleration. So final minus initial, final is a stop. So that's a 0 minus 8. 8 over 5, negative 8 over 5 is this much, negative 1.6 meter per second squared. Okay, so that's my acceleration. For the third required, get the total distance covered. We said that gagamit tayo ng area, magsasolve tayo ng area under the curve. Here we have 3 areas. So we have here, what's this? A triangle, a rectangle, and again, a triangle for segment C. So parang ganito yung magiging overall formula mo, no? So here is for segment A, this one is for segment B, kasi rectangle siya, and segment C, another triangle. So again, just plugging in what we can get from the graph. So the base for letter A is 4, obviously. This is the base. Height nilang lahat is 8. This is the height. So 4 and 8. 6 ang base. This is 6. Again, pantay-pantay naman ang height nila. That's 8. And then here is the base is 5. and then the height is also 8. Okay, so just getting my calculator and solving it, I got a 16. This much area is 16 meters. This much is 48 meters. And then this much 20 meters. And then to get the total, I have to add them. The total is 84 meters. Okay? Sige. It's not just it's not just you cannot just use displacement or distance is equal to v times t, because remember this can only be used if the speed is constant, right? If the speed is constant, just multiply that speed times time with time, and you can get the total area, or the total distance rather, covered by the object. But since this is a change, there are changes in velocities, right? Sa A, iba yung there is an increase in velocity at A and then a decrease at C. Sa letter B lang naman siya naging constant eh. So we cannot just use this formula. This would be wrong. Instead, you need to get the area under the graph to get the total displacement or the total distance covered. Actually, there's an alternative solution that I thought you might, or you should know, or you might like to know. You would need to use this formula. Displacement is equal to the initial velocity, just multiply it with the time, plus 1/2 acceleration times time, and then you will square the time. Okay? So, dalawa ang time mo dito. Pareho lang dapat yung entry mo dito kasi pareho naman silang variable. You have to do this on all of the segments. So, you will use the formula 3 times for A, B, and C. So, for example, for segment A, ito yung values mo. Ano ba? Ito yung initial velocity mo kasi remember, you are starting here at 0 meter per seconds. Ang time mo naman dito is 4. So, this appears here and here. Remember, we also solved for acceleration a while ago. So, that's an acceleration of 2. This will cancel out already because of the 0 here. Ito, pag kinuha mo to, makukuha mo ay 16. Remember, we also get 16 by getting the area. How about for segment B? So, my starting velocity is 8. This is my starting position, right? My starting velocity is 8. And then my time is 6 seconds. So, you have 6 here and 6 here. I have an acceleration of 0, obviously, since there's no change in velocity. The acceleration will be 0. So this time, this portion would cancel out, and you have 8 times 6. That's 48. The same with the area that we got from a while ago. And for our segment C, this should be small m. For segment C, my starting velocity is 8 meters. So, diba, it's initial velocity times time plus 1/2 acceleration times time squared. Okay, so this much is 5. Actually, I'm wrong here. It should be 5. But what you would get is 20 meters. The same with the area that we calculated here. Siyempre, kunin mo yung addition o yung sum to get the total distance covered. And the answer is the same, 84 meters. Okay? So you can use this one, you can use this formula in the examination. You can use this formula in the examination. Okay, let's try to evaluate acceleration at A and C. At A is 2 meter per second per second. At C is 1.6 negative meter per second. Negative because it's decelerating, positive because here it's increasing in velocity over time. Saan mas mabilis mag-change ang velocity? It's on segment A. I guess you can also see that in the slope, no? Relatively, konting mas mabilis o mas matarik, mas mag-change o mag-increase there with segment B because this only happened over 4 seconds, this over 5 seconds. So a little bit more gradual in the changes in velocity at segment C. Total distance covered, we covered a lot of distance at segment B. Obviously, we can see it on the area as well. That's also because it happened for a longer time, over 6 seconds. Okay, so this is the problem I'm talking about a while ago. Um you can apply the two solutions in getting the distances, because here you are also asked to get the total distance covered by this time the train. Try it. Maybe it would suit you better. Okay, good luck.